Hey guys, still here at the Supermicro booth at Computex 2024. I got my friend Yu here to talk about a couple of different systems. This is an oldie but a favorite. This is our AMD platform, right?
Yeah, this is the AMD platform and featuring like the storage, like petascale storage. Okay.
Yeah.
So if you are seeing the front side, you can see like there are different two type of the form factors right here. So this is what we call the E3.S module.
Yep.
And then the E3.S module is a type of like connectors right here. And then the thicker one is actually the cage that we can support the CXL module.
Okay, so we got CXL and
E3.SL,
okay.
E3.S and then E. Yeah.
You had me confused. I thought you were going to tell me these were U.2 for a moment.
Yeah, this looks like U.2, but this is actually for the CXL module. Yeah, so CXL module is basically for the extended memory usage. So basically, if you don't have enough memory, you can just put a CXL memory module into this space, and then the system memory can be expanded.
So what kind of applications are you seeing that need the CXL today?
The CXL right now, it's a kind of an early stage, and then now people are using that for the memory module expansion, as I mentioned. So basically, there are 32 DIMMs right now in the system right now. If like people doesn't feel it's enough, then they can expand the memory pool from this module.
This is a single 4th gen or 5th gen to support the new Zen 5 CPUs?
A Genoa CPU.
Genoa CPUs,
Yeah.
Okay. Awesome, well I see some new stuff over here. Let's go take a look at that.
Let's go take the new stuff.
Okay, so this is the new stuff. This is the X14. This is a really exciting thing.
Yeah, I'm really excited to introduce you our new platforms. It's called the new Cloud DC MHS. So have you heard of DCMHS before?
Oh yeah, of course.
Yeah. So now this is our latest and newest. So Supermicro previously, we don't have the DCMHS system yet, but in X14 generation, we came out a series of DCMHS systems.
Okay.
Not just like from the front side, not just the U.2 form factors version, we also have the E3 that as we just showed for the DCMHS system. Let's take a look at it inside.
Yeah, let's pop it open. I haven't seen these yet.
If you heard of like DCMHS system, it's basically an OCP defined spec, right? So this is the UP version. It's called MDSDNO platform. So there are two different type of form factor of the motherboard. One is the full width MFLW. And then the smaller form factor is SDNO, which means scalable, density optimized.
Yeah,
server.
you see the motherboard doesn't take up very much room in here actually.
Yeah. And then everything is all modularized. So basically, if you can see this is just a motherboard. Right. We don't have the BMC, we don't have the BIOS on this motherboard. We utilize the module called DCSCM module.
Okay.
So we put a BMC module and then a BIOS module into that specific module and then put it into that. With doing that, so whenever like the BMC or like the BIOS is broken, we can just simply swap a board.
Okay.
Yeah. And then everything is all modularized. The power board, the M.2 board, or like the fan boards, everything is all modularized. Like if a small part is broken, you don't need to swap the whole system, just based on the component.
I see this. These look like M.2 slots and a PCI cable. That's kind of an interesting decision there.
Yeah. So basically, this is all defined by the DCMHS.
Yeah.
So to support M.2 with the SDNO servers, we are separating the M.2 board with the motherboard.
Another interesting thing that I'm seeing is the power that's coming over to the motherboard. Looks like it's only 12 volt power?
Yeah, it's all 12 volt. And then we'll transfer it to different voltage like on the motherboard.
Okay, so the motherboard's handling the different voltage regulation. And what do we got for storage up front here? I see U.2s?
Yeah, like the normal version we have right here is like 12 drive base with the U.2 or like SATA support also. And then we also have the different version with E3 and then E3.S and a CXL support like that one that we just showed.
Okay, very cool. Then you can get them where the drive bays would fill out over here.
Yeah, so we also have a different module type, like if you want a front I/O with our own design OCP module AIOM, then we can swap this to a different type of module.
Okay.
Yeah, and then if the customer has a special need, we also can do like the OEM style. We can mix the E3 modules or like E1.S modules with the U.2 module as well.
Okay, so you got some flexibility on the platform as well. So the X14, you've gone pretty much OCP standard across the board with all the stuff in here.
Yeah.
This is the Xeon 6 support, so it's going to do both Sierra Forest and Granite Rapids when we see that coming out.
Yeah. So basically, this is supporting the Xeon 6. So Xeon 6, we are having a larger portfolio for the UP systems. As you can see, we designed these like UP systems for the DCMHS series, right?
Yeah.
Because like we are seeing more and more cores with a single CPU right now. So for the cloud data centers, like with the budgetary cost, then we probably single CPU might be making more sense right now.
Okay.
Yeah.
So that's really cool that you kind of have one platform and you can do the efficiency or the performance and really kind of design either a rack or a couple of different racks for different things. Maybe I have this server that has Sierra Forest in it and it has 144 WordPress sites that I'm hosting, and the one next to it is doing some scientific work in my colo. So that's cool, all in one platform and it's unified. So assuming parts are easier to get, less supply chain constraint because it's uniform. A lot of benefits out of these platforms. Let's take a look at the Dig 2U over here. So I see Pat signed this one.
Yes. So this is actually our hyper servers. So hyper series has always been our the flagship of Supermicro. So basically, this is a 1U, 2U type of servers with the signature of Pat.
This is worth extra now, right?
Yeah. This lid probably worth maybe 1 million, probably.
I don't know, Pat, are you that famous? So looking inside this guy, I see you got double sockets here, and I got the T-shape, some more OCP.
Yeah, so there are two OCP in the rear side, and also it support up to 8 PCI slots. So totally we can support up to 10 PCI device. So 8 standard PCIe plus 2 OCP modules at the rear side, and it also can support up to 4 double with GPU. So for example,
so I can get GPUs in here, kind of general purpose hyper server. It's the hyper server we know and love, but it's got some twists because we're going the OCP, new Intel platform. I'm assuming I can get this with all NVMe bays on the front if I want.
So with the 8 drive, it has a better thermal survivability for the GPU, of course. But if you want more storage intensive, we can put more drive base right here to support up to 24 NVMe's.
Okay, very cool. Well, X14 seems like a really exciting change in the thought process of Supermicro from the design language. Adopting these open standards, that's a big thing these days. Everybody wants everything to be open source as possible. So glad to see it. Really excited to get these into my lab to test them. All right, now I got my friend Jeff here to talk to me about Intel's Gaudi system. This is Gaudi 3, also new for this event, right?
Yeah, this is our latest server for Intel accelerators, the Gaudi 3 systems. So, for our systems, the Gaudi 3 delivers unparalleled capabilities for the LLM and training and inferencing in this market. So, Gaudi 3 boasts a remarkable performance per watt and a high price performance ratio, and there will be the cost saving for your inference and training.
Okay.
So,
what CPUs does this have? This has the new Granite Rapids?
For our CPU, we're using the Xeon 6 for this Gaudi 3 server. So,
Wonderful. And what do we expect for availability on this?
If you think about the AI training servers, we will focus on the Gaudi OEMs. And exactly, yes, we are using the Xeon 6 to process the data set, and they will enhancing to speed up your training and inferencing, and with the OEM, without the OEM. So if your data flow get into the OEM, you need to pre-process it. So this is will workload on the Xeon 6 on your CPU. They will be going to the OEM systems. So
Oh, look at that.
Sign here.
We got more signatures inside. I like the logos on these. Everybody's doing their own thing. AMD's got their little lunchbox looking one. Gaudi and NVIDIA look pretty cool. I got the nice blue in there. You see the switches up front, nice and cool.
So for this, all ports is for 800 gig for each port.
Each port is 800 gig.
For the previous version, the Gaudi 2 is for 400 gig. That is always increase the HBM bandwidth and memory capacity, so you need more bandwidth for your external core.
So I see a lot of similar design philosophy across the whole Supermicro portfolio. Put the GPUs on top, get a different thermal section in the bottom for all the CPU workloads. So pretty cool stuff we got going on here. Awesome. Well, thank you so much for the tour of Gaudi. Excited to see what this guy can do. Thanks, Jeff.
Thank you.
Check the link in the description. We've got a write-up on these X14s for the press release. We'll also have a link to the Supermicro site where you can find out more information. For now, make sure you subscribe. Check out all the other GTC coverage. We've toured the entire Supermicro booth. We've got a lot of awesome stuff here. See you later.